All right, so you said number 11. All right, number 11 says 6n to the negative second power, d to the sixth power, over 3n cubed, d to the negative fourth. Now, what is the first thing we should do with these problems? What's the first thing we should do right off the bat? Flip the negatives. I would flip all the negative exponents first. Can you see from that angle? Sure. Okay. I'd flip all the negative exponents first. So now let's rewrite it. Don't do any other math yet. Don't simplify. Don't do anything yet. Just flip all the negative exponents. Number 11 on the exponents and division worksheet. Let me see here. So now we'll have 3n cubed n to the second. D to the sixth stays up here. D to the fourth is the reciprocal flips it up top.
Now do we add them?
So now you start combining them, right? So I don't want to say just add right away. I got to look and see where the variables are placed. But now you want to start combining the like bases. So first of all, what's 6 divided by 3? All of you, that was very slow. What's 6 divided by 3? Okay, so now we're going to simplify that. 2 is a part of the numerator. Let's keep that there. D to the 6th times d to the 4th. What law is that? Nope, not quotient law. Product, right? Because the product is the answer to a multiplication problem. So since now we are multiplying with them having the same basis, it's product law. So product law, we do what with the exponents? We add them, right? So what does this become? D to the what? D to the 10th over, what is that on the denominator? It's not going to be 1 to the 5th.
It's going to be 1 and 5th.
So just n. We can leave just n to the 5th.
If we put a 1,
you don't need it. Like, what value does it have?
What would you mark it down?
Yes, because it doesn't have any value. So like, put it like this, right? So let's say we had a problem that was let's say we had 16 divided by 8, and your answer is 2 over 1. It just doesn't make sense to write it. It's just 2. It's 2. You know what I'm saying? So.
You know how the 2 b's are negative?
Shh, hold on real quick. One question. What you got?
For number 10, do you know how the 2 b's are negative? It's negative 3 on top and negative 5 on the bottom. Do we flip them too?
Yes. Whatever has a negative exponent, you go ahead and flip its position to the other side of the fraction. Okay. What was your question? Another problem you want to see?
Oh, wait, no. It's because
Should I do 10?
Yes.
Okay, let me just do 10. But what's your question? Go ahead and answer it.
I was just going to say that is number 11. If we didn't do it the way you did it, but still got the same answer.
Oh, yeah, no. With exponents, there are several ways to do them. So as long as you got that as an answer, you're great. The one thing I like about mathematics, you can do it so many different ways, but you will come to one answer. As long as you got that answer, but you did it your other way, I have no problem how you did it. There's several ways you can approach these problems. That's 11. Now I want to do 10. So number 10, 3w to the negative 4th, b to the negative 3rd, over 9wb to the negative 5th. All right, first thing we do is just we're going to go ahead, rewrite it, and flip the negative exponents to their proper position. So I'm going to keep 3 over 9. I'm not even going to simplify that. Just leave everything. W stays down here. W to the 4th flips down. B to the 3rd flips down, and then B to the 5th comes up top. So whatever has a negative exponent, just flip its position.
Oh, crap.
When you do that, when you find the reciprocal, it's positive. That's why we do it.
So you just flip the sign?
I don't flip the sign. No, I flip its position in the fraction. If it's a numerator, now it becomes the denominator with a positive exponent. If it's the denominator, now it's numerator with a positive exponent. So I flip its position, not just the sign. So now 3 over 9, what does that reduce to? Say it again. 1 over 3, right? So I don't need to put the 1 because I have a value up there in the numerator. So I'll put 3 at the bottom. I think I put it too far over. Let me scoot it over a little bit more. So 3 will go right here. Now w times w to the 4th, what is that? W to the 5th, perfect. And then I have b to the 5th over b to the 3rd. What law is that? Quotient law, right? Because you have the same exact base. I can slide it over here. I have the same base, and I am dividing. So when I divide, what happens with the exponents? I subtract them, right? So it's 5 minus 3. Now, b to the 2nd, where does that solution go? Numerator or denominator? Numerator, right? And an easy way to look at that one is what position has more b's? Is it the numerator or the denominator? Numerator is b to the fifth. So now if you wanted to expand it, right, I can go b to the fifth over b to the third. So I can have b times b times b times b. Ooh, that looks nasty. Times b over b times b. Leave me alone. Times b. So, that looks like a nose. So now I'm going to just go simplify, simplify, simplify. How many are left? 2. Where? Numerator. So, easier way to do it is just looking at what position has the most amount of that variable, and that's where your solution will be. Yes?
I had a question about quotient law. So, like, if it wasn't a variable, the b's, if it was, like, if you look at number 1.
Number 1, hold on. Let's stop right there. So, hey, number 10, does that one make sense for number 10?
Yeah.
We okay on that one? All right, you said number 1. Let's go to number 1. What's up? I want to get this answer before I go to Catherine's question. Caitlin, my apology.
When you subtract it, you only put it
Exactly. Yes, of course. Because I showed it up here, right? I have 5 b's up top, three b's on the denominator. When I simplify the ones they have in common, where does your solution go? Right.
How do you get W?
Right here. W times W to the fourth. That's product law. The same thing we did for the first problem up here, man. Did the same thing right here. Did the same thing right here. D to the 6th times D to the 4th gave us D to the 10th. This gave us N to the 5th. So it's the same thing. All right, you said number 1, right? So let's go to number 1.
We're doing number 1?
That's what I'm doing right now. So, number 1, 8 to the negative 5th over 8. What's the first thing we should do? So we should find the reciprocal, Caitlin, right, of the one that has the negative exponent. So now when I do that, I have 1 up top over 8 to the 5th times 8. Right?
So be 1/8.
So, and if that is confusing, right, let's look at it this way. I can separate both of these fractions. Does that make sense there?
Yeah.
That's the same thing. So this right here is the same exact thing as this. They say the same thing. I just broke apart the fractions. So now if it helps you, let's go ahead and now flip the one that needs to be flipped, right? That's the first one. So then it becomes 1 over 8 to the 5th times 1 over 8. See what I'm saying? So then now we just go ahead and combine both fractions. 1 over 8 to the 5th times 8. But now we have that same product law. Same base, multiplying, add the exponents. It doesn't change. So 1 over, what would that be? 8 to the 6th.
The way I did it, I didn't do all that. I just did 8 and then negative 5 minus 1.
Minus 1?
Yeah.
That's fine.
8 to the negative.
And then flip it. Perfect. Doesn't matter.
It's because I was just a little confused on like whether the 8's cancel out or not.
No. You're just multiplying more 8, so it wouldn't cancel out. It's 8 to the negative 5th, so it can't cancel out. Like, you know what I'm saying? If it was 8 to the 5th, then you can expand it. It's to the negative 5th, so you have to flip it before you do any math with it, so it wouldn't cancel out right now. Yeah. Yes, you would. So you guys have graphing calculators. You simplify 8 to the 6th. What is that? Say it again. What else? Yes, that'd be your final solution.
I have a question. For number 6, since we don't have to do any flipping, do we just like leave it?
No, the 9 and 4 can't be simplified, but then into the 5th, that can.
So we just subtract it.
Yep.
And then it'll be n to the 4th.
Yes, where would it go?
On the top.
No. You have 5 ends on the bottom, right.
So n to the 4th.
All right, the back worksheet. Go to the back. I can work out, let me see how much time do I have. I can work out probably like 2 of these. I have 1 minute and 48 seconds left. So I can do 1 of these. So give me a good one. Look at that. What's a good one you want to see? They're almost all the same though.
13 was only 1.
I'm hearing 13 was a weird one. 18. 14. All right, I can look at 13, not an issue. So 13. It's not, but it's good to see how to do it anyway, though. So for 13, we have 8w times 8 to the 6 over 8 to the negative w times 8 squared.
It's not for
I messed up somewhere? Minus w, my apology. Okay, there you go. So is that right? Am I good? Okay, so now what's the first thing I should do?
flip.
The one has a negative exponent. Let's go ahead and flip its position. 8w times 8w times 8 to the 6 over 8 squared. Okay, now what? Now what should we do?
Can we add the so it just be 8 FW squared?
Well, it's not squared because I'm not multiplying them,
You're
right?
adding
I'm adding. So what's w plus w?
W squared.
W plus w is not w squared. 2w is 2w. P plus p is 2p. I have two p's now. It's 2w.
Wait, can exponents and other exponents?
2w. How many w's do I have? 2.
No, but
Two
can
W.
exponents have other exponents?
Got to see examples. Probably can, but I got to see what you're talking about.
Like,
Not right now, though. I'm going to do this problem first. All right. It's the last problem. So 8 2w, and now what do I do with the 8 to the 6th, 8 to the 2nd? Subtract. What is my answer?
8 to the 4th.
Where does it go? Perfect. 8 to the 4th. But now I have the same base again. So now what do? I don't know where you got 1 from. I have to add them, right? They're the same base. Add the exponents. 2w plus 4. You don't have this on the quiz at all, but you're still doing the same exact laws. It just looks different. But we're applying the same things. W plus W has been 2w since you were in 6th, 7th grade. That doesn't change. It just looks weird now that it's exponents. 2w plus 4. So equals 8 to the 2w plus 4 power.
That's the answer?
It is. It's weird, but that's the answer.
Oh, that makes sense.
We just follow just basic, exponential laws. The laws didn't change. It just looks a little different with the way the answer came out. But all the laws still stayed the same, though. No. No notes. You know what? Yeah, go ahead. Let's see if it helps you.
What?
Gustavo's always asking for notes.
No,
Because he doesn't do his work.
Oh, of course.
So he wants the notes.
Never mind, I don't want
to. You're not messing with what you do. Yeah, no, go ahead. You use them. I'm not worried about it.
These are notes.
See what it does. I'm confident in these problems that the notes may or may not help you. Either you know it or you don't.
Think about it.
Are we factoring trinomials?
Not this is exponents. That's all this is. It's exponents. You'll have 20 minutes for this. I'll start the timer when the last paper is passed out. Yeah.
So, Nicky, can we use this? Can we use this?
Sure. Let's see what it does.
Oh, yeah.
Calculators. I would have one anyway, just because you may have to do some big simplification. I think you do. I don't recall, but you might just get one anyway. So if you can change your positions at your tables, sit on the edges in the middle.
Wait, what?
You know how we do whenever we do a quiz. Not shoulder to shoulder, where it's an easy peek over. Let's roll. You only got 20 minutes. Let's go. Let's go. Get notes out. Move the tables and chairs. Thank you, sir. I appreciate your time. You may need a calculator for simplification. I think you might. Let me see. Caitlin and Brian have sat down. They're done. So, okay. They pass papers out. Timer starts. 20 minutes.
Well, we need a calculator, right?
I already said you might need one. Just best to have one for this.
Is this fit?
Today is the 5th, yes. I was recording that whole time, dang it.